How many empty seats do we have? 1, 2, 3. Wonder if we have enough seats for everybody.
You over here.
It's supposed to be 30. So hopefully we have enough. We will get started in a minute. Yeah, I might ask to get a bigger classroom. So I'll send an email if that's the case. If we switch classrooms, I'll let you know. Okay, so it's 12:30. Good afternoon. It's time for us to get started. Finally, back to the face-to-face strategy. I'm gonna be wearing my mask. Hopefully, with the mic, everything is gonna be good. So if you have any issues listening to what I'm saying, just let me know. And we're going to continue our discussion. We started our discussion last week on the different type of planning from the product perspective, process perspective, and schedule perspective. And we work on some problems. You have the opportunity to work in a lab, and also there's an assignment, I believe is due on Wednesday. So make sure that you start working on that if you haven't started yet. Office hours, just want to let you know, have office hours Mondays and Wednesdays in the morning from 9 to 10, and in the afternoon from 3:30 to 4:30. So after this class, I'm teaching another class, and then after that, I'm going to be available. Office hours are online, so you can find the link to connect to the office hours in the syllabus. Mentioning everything just because this is the first time that we're meeting face-to-face, so I just want to put those announcements out. What else? Yeah, so the lab, we have our first lab, so we are going through the grading for that. I expect everybody to do very well in the first lab. So remember, lab exercises are in-class exercises. You start here, you work with me, the solution, and then you upload that solution after the end of the lecture. So please keep that in mind. If you don't come to class, remember that I'm posting the videos and I'm also doing the hybrid session. So you can also watch the video online live. So right now we have a live session going on through Zoom as well. And then everything is gonna be submitted via Canvas. Modules are posted also via Canvas. If you go to the modules now, you'll see the slides for today. And we're gonna have a lab, we don't know if we're gonna start it today or not, but we'll see. Any questions? No, good. So let's get started. So today we're gonna transition to our second lecture, which title is Flow and Activity Relationships. And we're gonna study the different type of flow that you are gonna encounter inside a facility, not only inside the facility, but also how the inputs and outputs from the outside the facilities also affect the processes that are happening inside the facility. We're also gonna discuss in terms of flow, how to design manufacturing cells in the sense of knowing what type of products you have available and also how many machines you have available. And then based on that, make a decision in how to design a manufacturing cell. So we're gonna discuss an algorithm for those purposes. And I think that's gonna be the end of the lecture for today. So just wanna give you that heads up. So let's get started. So as always, I start my lecture with presenting the objectives for the semester, and I'm gonna read them today, but these are the things that you need to know by the end of the semester. So after you take this class, you wanna check on yourself whether or not you are knowledgeable about these 4 topics. principles of facility location, formulations in terms of designing facilities, material handling. We're going to talk about material handling, and also finally how to incorporate product, process, and personal requirements into the design of the facility. And the agenda for today is here. We're going to go through most likely the first 5 topics today. An introduction, what is flow systems, material flow system, how to plan for the department. So again, when we think about, if your phone is ringing, make sure that it's on silent. So when you're planning for a facility or designing a facility, when you think about the inside of the facility, first thing is how you're going to split this area into multiple departments. And once you have those departments, how are you going to plan the inside of those in terms of the manufacturing process that is going to take place, the machines that you have available, and the products that you're going to be manufacturing. So we're going to touch on some of those things today. Okay, so the learning objectives, understand the interactions between flow systems. Okay, so flow inside the facility, what's coming in, what's coming out, flow activity relationships, and the space requirements as they relate to our main goal, which is the design of a facility. So let's begin with understanding what, from the facilities planning perspective, what flow systems is. Sorry about that. So flow system, look at the movement of goods, materials, energy, information, and or people inside the facility. So we often refer to this as the entities. What is going to be moved through the facility? Are you going to be planning for a facility like an airport where you're moving people, or you're moving the luggage, or you're going to be planning for a manufacturing facility in which you're moving a specific good or product or materials, or are you planning for, let's say, a power utility company, which you're moving energy or a gas type of company? So what we refer as flow system is the movement of such entities within the facility. A flow process might be described in terms of the subject of flow, the resources that bring that flow, and the communications that are needed to coordinate the resources that are needed to make those flows happen. Okay, so the subject is the item to be processed. The resources that bring about flow are the processing and transporting facilities required to accomplish the required flow. And the communication, obviously, this is where the resources are coming into play, include the procedures that facilitate the management of the flow process. So you have the entities, but the entities are not going to be moving by themselves. So you need to plan for the resources that are going to be needed. So this could be an operator, or this could be a machine, material handling equipment, or the combination of both. Flow systems for discrete parts. When we say discrete parts, these are things that you can count, right? We think about energy. You don't necessarily have a unit measurement for a pound of energy, right? You have a continuous flow. But flow system for discrete parts, or for things or goods that you can count, can be categorized according to the stages of the supply, manufacture, and distribution cycles. And the 3 categories are the materials management system, material flow system, and the physical distribution system. So here in this first figure, you see the relationship about these 3 categories. So at the top, you have the vendor, and at the bottom, you have the customer. The vendor can be your supplier, someone that is supplying some type of material or a part that you're going to need to develop your product. And then from there, you have the material management system, which is going to be planning what's going to coming into the system or into the facility, the material flow system that is going to take those products and it's going to direct them to the right machines or the right department so you can work on those. And then once the product is completed, you can have the physical distribution system, which is in charge of delivering those products to the actual customer. So the materials management, material flow, and physical distribution system might be combined into one overall flow system. And that overall flow system is represented here in this first figure. But we know that inside each of these categories, there's a lot of things happening. Right? I'm going to look at those now. Such an overall flow process is referred as to the logistics system. This is a very popular word nowadays, logistics, supply chain. So that's what we refer to. So from the vendor to the customer, all the things that are happening to create, move, and deliver that final product. And all that is connected to the actual facility, right? So once you get the parts, a lot of things are happening in here, inside the facility, and then the customer has to get the product from the distribution system. So let's look at the first part. Once we get the supplies from the vendor, what is the material management system? So material management system, look at the flow of materials into a manufacturing facility. How things are going to come into the facility. The subjects of material management systems are materials, parts, and supplies. So this is like the supplies, again, that are needed for you to create your final product. These are purchased by a firm and required for the production of its product. So if you're looking at the cell phone as your final product, you might get different chips, boards, and so on. The screens, you might get all those from a supplier, and then you deliver or you put them together. You have the software piece and so on. So you put together a product to be delivered to your customer. The resources of this materials management system include this list: the production control and purchasing functions. Okay, so you need to keep track of what you have in inventory and what you don't have, right? So that's what we are doing at this first step. So the production control is going to look at your inventory. We have enough for production this week, or we don't have enough. So we need to put a purchasing for our supplier to bring those parts that are low in quantity, so we can continue our production. The vendors are our suppliers. Okay, so sometimes, as we discussed already in our first lecture, we can manufacture our own parts inside the facility, or if it is less expensive, and if you have a supplier that is reliable, might be cheaper, or it might be a better decision just for you to get those parts from a vendor. The transportation and material handling equipment required to move the materials, parts, and supplies. So it's not just bringing those parts into the facility. Once they get into the facility, you have to find, or you have to have a plan to get those parts into the facility, storage. If you have parts that are can be damaged by temperature, do you have an area to place those? So everything requires a planning. So you also need to have some specific material handling equipment. And if it is something that can be damaged easily, you might not want to have an operator bringing those boxes by himself to the facility. You might want to have some type of conveyor or equipment that is going to help you take that safely from the dock into the facility. The receiving, storage, and accounting functions. So once you get an order from the supplier, you're going to put in your accounting books, you're going to make a payment, and so on. So all those activities are part of just the first part, right? The material management system. The communications within material management systems include production forecasts, inventory records, and stock requisitions. So if you're an IE, industrial engineer student, maybe even the manufacturing ones, you should be familiar with forecasts. So basically you're trying to predict the future in terms of, okay, what's gonna happen? And that could help you plan for what you wanna do on let's say in production, from the production perspective, how much you wanna produce in terms of the forecast on how much you're gonna sell in the next 2 weeks, 3 weeks, and so on. Inventory records, again, I'm gonna look at how much you have, and you say, okay, I'm gonna be selling this many units in next week or next month. So I might need to bring more parts into my facility to make those meet those production schedules and the stock requisitions. So are you going to bring those when, and so on. So here's the overall schematic of the material management system. And this is a summary, but it encapsulates most of the activities. So you have a key at the top. Here's the flow subject, the resources, and the communication that needs to happen. So from the beginning, you see the forecast happening here at the top. This is how much I predict based on historical data, based on the seasons, based on everything that is happening, let's say the pandemic, how much I'm going to be selling or I expect to sell in the next weeks. And then based on those forecasts, you're going to start planning. Okay, so production control, you're going to make those requisitions. So you're going to need these many parts, you're going to be needing these many products to be manufactured. So the purchasing department is going to put those orders. Okay, so you're low on those areas. Let's say these items are not available, so you need to bring those before you can schedule the next batch. And then you contact the vendors. Vendors get the orders, the bill of landing, transportation from the vendors to the receiving departments. Once you get the products, the accounting is going to be involved to pay the vendors. And then from the receiving departments, you're gonna put your products from the receiving to the inside the facility. So you have some type of material handling happening. And then once you get into the product, are you gonna put them into your warehouse? And if that's the case, then you need to update your inventory records. So we are not, I mean, you're looking just at the process of getting parts into the facility, and that's what we are doing here, materials management system. Any questions? And you can see there's a lot of people, a lot of groups inside the facility or inside the company that are involved in this process. All connected to what we are trying to do in terms of facilities design. So, for example, if your forecast, let's say you have a lot of sales happening every week, you need to bring a lot of materials into your facility to meet those requirements. Your facility design needs to look at how much space you need to have in terms of a warehouse, right? And your design should accommodate those needs. Also, the material handling. So are you moving materials really fast? So what type of material handling do you need to have in place in your facility? And remember, material handling system occupies some space. So if you're going to design your facility, you need to take into account the amount of movement that you have, how much material is being moved into the facility every day, and then decide what type of material handling you're going to use, how much space that's going to use, how is that going to affect the design of your warehouse. And we're going to look into those details later this semester, but I just want you to start looking at this and say, okay, how is this connected to the material in this class? So facilities planning, remember, you have to look into those areas, material handling, store department, how much space do we need in order to design our warehouse. Okay, so from here, we move into the material flow system. So we got the product into the facility. Now we look at how to move that material, those products, into the actual manufacturing floor. So material flow system, the flow of materials, parts, and supplies within the facility. The subjects of material flow systems are, again, the materials, the parts, and the supplies that are used in manufacturing products and components within this facility. Okay, so we brought the materials, the parts into the facility. Now we are concerned with the flow inside the facility. The resources of the material flow system include the production control and quality control departments. So remember from our previous discussion, we were trying to plan how many parts we needed at the beginning of the process so we can get this many and we can send them to the customer. So if we needed, let's say 300, we know that at some point we're going to lose some of those parts because of defective rates and so on. So we needed to plan for the beginning of the process, how many we need to begin with. And that is involved with the production control and the quality control departments. Quality control is going to look at, okay, this part is good, let's pass. You can pass to the next step. quality control can say, okay, this is not good, so let's rework or let's discard this part. The manufacturing, assembly, and storage department, material handling equipment again, it's involved. This is to require to move materials, parts, and supplies within the facility and the factory warehouse. Communication includes production schedules. So again, you make those forecasts. Now you say, okay, I'm gonna be selling 1,000 units a day. So how can I set up that in order to meet that demand? How much time do I need? How many parts are gonna be produced per machine? How many production lines are gonna be running at the same time so I can meet those goals? All that is connected to the schedules. Work order releases, move tickets, Kanbans. So if you're not, you don't know what the Kanbans is, this is connected to the just-in-time production method. And we're gonna also discuss that in class, but there's some cars happening, moving around the facility. And when you have a low inventory, you change the color of the car and then indicates that you have to bring more parts into that station. So we're gonna discuss that in class, but for now, it's just a part of a manufacturing process. Barcodes, route sheets, assembly charts, and warehouse records. And again, as we did for the first one, this is the overall flow for the material flow system. So we have a production schedule. As we said already, we have a forecast. Based on that forecast, we're gonna indicate how many parts we're gonna be producing per product, let's say per week. And then based on that, we're gonna start planning for our schedules. So how many shifts we're gonna run, how many machines are gonna be occupied for a specific product, and so on. So that's connected to the production control. We go to the work order release. We go to the material handling. You're gonna be moving the parts into the facility, into the manufacturing departments, and then to the assembly departments. And once the product is completed, we bring that to the warehouse. If it is not moved immediately, we put them in the warehouse so they can be moved to the customer, and we update our records. So that's inside the facility, right? We talk about how to get the parts into the facility, now the movement inside the facility. And now we're going to discuss the physical distribution. So now we have the product ready. How do we move it outside the facility? So that's what we're going to discuss in the physical distribution system. So physical distribution system, this is the flow of products from a manufacturing facility. So again, we're done with the process of producing this part or this product. Now we want to move it to the customer. So the subjects of material flow systems are the finished goods produced by the firm, cell phones, laptops, food, anything that you can count in terms of a product. The resources of the physical distribution system are the customer, the sales and accounting departments and warehouses. So now we're dealing mostly with the warehouse because the products are ready. The material handling and transportation equipment required to move the finished product. So if we're gonna move this from warehouse to a truck, we're gonna be using some forklift or depending on the type of product, right? So, and then you have to have your own trucks to move this to the customer, or you're going to be moving this from the manufacturing plant to a cross dock, in which you're going to be distributing that to different stores. For example, H-E-B or Walmart. They will have this manufacturing, mostly warehouses in which they store their product, and then from there, going to distribute across the state. So they not necessarily deliver from the warehouse to the customer. They might have other facilities in between that are helping in the distribution by means of, let's say, bring all the ice cream to San Marcos, and then from there we're gonna take that to different trucks, and they're gonna be distributed in the Central Texas area, and so on. So So material handling and transportation equipment required to move finished product can include also those delivery trucks. And the distributors of the finished product. The communication includes sales orders, packing lists, shipping reports, shipping releases, canvas, and the bills of landing. So these are all documentation that needs to happen once we have completed the distribution. And here's the flow for the physical distribution system. So we start with the customer at the top. There's some counting information happening. So we need the customer saying, I need this much, like if you're talking about a supermarket, HEB supermarket, I need ice cream. So that goes to the warehouse, sales department, and then they're gonna go here in San Marcos, they're gonna go pick that product. And then they're gonna use the material handling. Most of the time they have this forklifts and putting together the order. And then for the material handling, we do the transportation and distribution to the final product destination, which will be the customer. So again, three areas, major areas. Final one is the physical distribution to the customer. Questions? So keep in mind, what we're trying to do here is to give you an overview. Okay, I mean, if you're not familiar, maybe you're familiar with flow within, inside, outside the facility, but if you're not, this gives you a good perspective, okay, of all the things that are happening within the facility. So it's not just the building that we are trying to design, but we need to take into account all these inputs and outputs that are happening when you're dealing with a manufacturing process. So now that we have an idea in terms of products that are moving, type of equipment that is needed, space that is needed, all the inputs and outputs, you can start thinking about the actual design of a facility. And we're gonna look at material flow system next. And this is gonna look at the different levels too, from the design perspective. We're gonna start with material flow system, and we'll focus on material flow system with emphasis on flow patterns and structures as viewed from the perspective of flow. So now we are looking inside the facility, within workstations, within departments, and between departments. Okay, so if we look at design of a department for a facility, could be something like this area that we have here in the classroom, and we can think about, okay, for you guys, students, what type of equipment do you need? Do you need a table, a chair to sit down, maybe a computer? So that's what we're gonna call the workstations. And then from there, we're gonna go up a next level and up a next level to understand the flow systems happening within the facility. So within workstations, within departments, and between departments. The flow within workstations, these are designs that are mostly looking at studies from an economic consideration. If you're an industrial engineer student, there's a class that focuses on that in IE 3360, which is methods engineering economics. But the idea is, you're gonna design a workstation for your employee or your worker in your facility. What are the things that you need to take into account? For example, if you're gonna do a manual assembly of a product, how far you can put the parts so you can reach them. And these are designs that are based on the average height, average size person, the women, female or male. You have to take those into account. And there's some measurements here that are typical from the ergonomic perspective. So if you're gonna locate parts in this workstation, you need to make sure that if those parts that are used frequently are within an area, like for the person to reach out without problem. And in those parts that are not necessarily used all the time, you can put them farther away from the workstation. And here's the area where the usual work happens. Okay, so again, looking at this from an assembly perspective, if you're putting together a product, you're receiving multiple parts and you're in charge of putting together an assembly, a sub-assembly for your product and so on. But for the perspective of from for our course, for this class in particular, I'm not gonna go in detail in how to design a workstation, because that's material that is covered in a different class. We're going to be focusing more in the next things, which are the flow within departments. So the design of departments, once you have your workstations, how are those going to be located inside the department? How many machines you're going to need inside that departments and so on. So flow within departments. The discussion will focus on flow within product, process, and product family departments. So the flow within the product department, it can happen in multiple ways. Product department, basically you have a department that is focusing on a specific product. That's all you do, single product. You don't have any other things being manufactured in that department. So if you're, I don't know, you're building just an iPhone, so that product will be that department is just going to be doing iPhones, right? It's not going to bring iPads or anything else into that department. So that's the design that we are looking at right now, a product department type of thing. So the flow of work follows the product. So here we have different layouts. So we have end to end, that's A, back to back, meaning that these dots are representing the location of the operators. So you bring this point, the product here that is moved to the next table. If it goes in this back to back, your product is moving in this direction, but it's being moved from this point to this point after it moves forward. Front to front, same idea, but now you have the operator in the middle. D is circular. This looks more like a manufacturing cell in which you're moving from one station to the other until the product is completed. And this is an odd angle, kind of similar to what you're observing here, but now you have operators in each station. Here you have only one. And then an odd angle basically means that you might have a column in the middle and you need to move the stations in this odd angle because something physical is there that cannot be moved. So that's the whole idea. So again, flow within the product department. These are some examples. Flow within a process department. So now we are looking at, let's say we have multiple machines that are, let's say, identical or similar, and they're grouped in the same department. So if your product needs to go through a specific process, let's say you have 1,000 products, and all of them have to go through a drilling process. So you have all these drills in one department, and then every time a product needs to go through that process, you'll bring it to this department to do the drilling. So similar or identical machines are grouped in the same department. A minimum amount of flow should occur between workstations within departments. And the flow patterns are dictated by the orientation of the workstations to the aisles. The determination of the preferred work aisle arrangement pattern is dependent on the interactions among the workstation areas, the available space, and the size of materials to be handled. Okay, so we talked about the product focus department. Now we have a process, all these drills. You have all your products that have to go through this process. So that's why it's beneficial for you to have all these drills in one department, because you know, since all of them have to go through this process, every time you need to go and to that step in the process, you can bring them to this department and you're gonna have enough machines to work on that. And here's some examples for flow within departments. So looking at the aisles, I think that's the major thing. You decide where the aisles are so you can have a flow going in these directions. In this case, you have two aisles, so you can move in any direction. And this is the same idea, but now you have this diagonal shape. So it all depends on how much space you have available, again, in the facility. And then flow between departments. So now you go outside the department, and the criterion used to evaluate the overall flow within the facility. This is what we call the flow between departments. And the location of the pickup and delivery stations for each department is important. So again, here in these examples, we don't have a specific delimitation for the departments. We just have an area that is representing the overall facility, and it's showing how the product is moving within the facility. But what you need to understand from this picture is that the location of that pickup and delivery stations, right? So at the top here, you see that door or to enter is located in the same area where the exit is located, right? So that means that everything is going in and out from the same location. And that happens here in A. In B, you have the input happening in this is called adjacent side. So you have the input coming from one wall, the output happening in a different wall. So that happens here and here. In C, we have on the same side, but it's not located in the same position. They're located in different corners. So you can go in from one area and then move out from the same wall, but at a different location. And then the flow happening, input happening on the opposite sides, right? So here goes in this wall, goes out in this wall. So the flow between departments basically is looking, okay, and deciding, you're gonna decide where the input and output is gonna happen. And then inside the facility, you'll be focusing more on that design, looking at these recommendations. So you have all these options. Maybe in this case, you're blocked from this wall, and this wall. So the only option you have is to have the input and output happening in the same area. But if you have more flexibility, like in this case, that should give you extra, maybe extra freedom in terms of designing the flow inside the department or inside the facility. So that's what we call the flow between departments. Focusing on that specific decision, so you can plan for the inside flow of the department. So the effective flow planning is a hierarchical planning process. So the hierarchy is here in this triangle. So you start with the effective flow within workstations, then you move to the next level, which is the effective flow within departments, and then you move to the next level, which is the effective flow between departments. The following principles have been observed so frequently result in effective flow. So maximization and minimization, these words are used when we're thinking about the optimization process. So maximize meaning that you're looking at maximizing whatever performance measurement you're looking at. So maximize is going to be the best performance that will give you the maximum value. Minimization, performance from a perspective of finding the decision that's going to give you the minimum value. So if we look at this principles, if we look at how to make decisions, for example, for effective flow, maximization of directive flow paths, meaning that you want to have a specific direction. The overall design, if it can have a direction that is not that is not allowing movement from one side to the other and backwards, you want a design that is going to maximize the routes that are going to have unidirectional flow. Minimization of total flow, meaning that you want to reduce movement as much as possible. right? If you can put together two departments that have a lot of interaction, you can put them close. That will minimize the amount of flow and movement that is happening within the facility. On the other side, if these two departments have a lot of interaction and you put them on opposite sides, you know the amount of movement that is going to happen is a lot. So those decisions are also important. And the minimization of the cost of flow. And this is connected to decisions that you're going to make in terms of material handling. So are you going to be using an operator in which you're going to be paying a salary, right? And you can somehow control the amount of fund that you need to support that operator? Or are you going to be investing in these high-tech equipment that could cost you a lot of money? So minimization of the cost of flow, there has to be a decision made in terms of type of material handling that you're going to be using in combination with the distance that you're going to travel. So in a perfect design, you will try to minimize the distance that you are traveling, and you're going to be using the right equipment that is not very expensive. So less expensive equipment that is going to give you the work done. Any questions, comments? Again, what we are trying to do now is I'm starting from the point of view that you are unfamiliar with these subjects, and I'm trying to give you as much information as possible. Yes, sir. Material and supply. So when we talk about material from the course perspective, we are talking about the input that is needed for you to create a final product, right? It could be I don't know, a part. It could be some type of, I don't know, board or a chip or a screen if you're looking at cell phones. Now you talk about supply, comparing at the supply. So the supply, it can be looked from a multiple perspective. If you look at the supply chain, you're looking at the processes that you're going to be using to deliver that final product. The supply product is going to be that final product, right? After you have gone through all the assembly, the processes, you start with some materials. This could be multiple materials that you're building them in some form so you can generate that final supply product.
So like would a build an iPhone? Would
Yes.
a screw be a supplier or would that be a material?
The screw is being used to put together the product. It could be a material for the final product. You need that screw to put together the final product. But the actual cell phone itself that you're going to be moving is the final product, which is going to go through your supply chain. I want you to get confused because the screw also comes from a supply chain, right? So, but it looks at from the perspective of your product, you're going to identify whether it's not a basic material that you're going to use to develop your final product. Yes, sir.
I think that material is something to look at as part of an internal basis, whereas supply is more of an external customer type of basis. You have to deal with all your service and product. Material is in-house. Supply is expensive everything outside.
Well, the materials, as we discussed in our first lecture, our input or materials that you need to put together the product can come from two different sources. It could be from inside the facility, and it could be also purchased from a supplier. Yeah, so from your point of view, yes, that's what we are looking at as from a material point of view, is that pieces that you need to put together your final product. And then the supply itself, or the supply product is that final product that you're elaborating in your facility that you're going to distribute to your customer. Those are good questions. Any other question or comment? Good. So now that we have all this information, again, if you want to go back to look at these slides later on, so you can get a better grasp of these concepts, that I would recommend you to do that. So now we move into the planning of a department from a perspective of building cells for production purposes. So I mentioned the design of a workstation from an ergonomic perspective. Material is probably outside what we're going to cover in this, outside the topics that we covered in this class. But now, once you have the workstations or you have an idea of how many machines are going to be inside the department, how do you plan for that department? So planning departments can involve production, support, administrative, and service areas. Production planning departments are collection of workstations, right? We talk about the design of the workstations to be grouped together during the facilities layout process. So if you're going to put together a manufacturing line, you need to know how many workstations are going to be part of the manufacturing line, how many machines are going to be part of the manufacturing line, and use that to define the layout of the line and the department. Depending on product volume, variety, production planning departments can be classified as product, fixed materials, location, product family, or group technology, or process planning departments. So product or fixed material location, product family, or process planning. And I like this graph that I'm showing here in figure 9, because this can give you, can guide you in terms of what type of department you want to design based on the type of product that you're producing. So for example, if you look at volume is the y-axis, and then the product variety is your x-axis here. So depending on the variety, meaning how many different products you have in your company, or the volume, how many of those you sell typically, you can decide which type of design is better for you. So for example, if you have a low variety and a very low volume, this will be a fixed location layout, what would be recommended. You have fixed materials, location, and planning department. If you have a very high volume and very low variety, then you have a product planning department. It's going to be a department that is going to be developing that specific product. And then the opposite, if you have very high variety and very low volume, a process planning department. And in between, if you have medium and medium, then the product family planning department will be the best strategy, in which you're going to have group technology layout. Okay, so let's look at this individually. This is a procedural guide for combining workstations in planning departments. So again, we have guidelines here depending on the type of product. So if the product is standardized and has large stable demand, the type of planning department should be a production line with product department. And the method of combining workstations into planning department should combine all workstations required to produce the product. So you're not going to have a bunch of machines that are the same in the same department. You're going to have all the machines that are needed to produce that specific product in the same department. And that's when you have a product that is standardized and has a stable demand. If you have a product that is physically large, awkward to move, it has a low sporadic demand, let's say like a yacht, right, a boat. You have a fixed materials location, product department, combine all workstations required to produce the product with the area required for staging the product. If the product is capable of being grouped into families of similar parts that may be produced by a group of workstations, let's say different Samsung phones, cell phones, that have shared parts, product family or product department, and it will combine our workstations required to produce the family of products. So if you have a specific model, it has some differences, but in essence, you have multiple processes that are the same. You can combine those workstations and then have a route for each one of those products, and they will skip the stations that are not needed, and it will use the stations that are needed. And if the product is none of the above, then you have a process department that combines identical workstations into initial planning departments and attempt to combine similar initial planning departments without occurring important interrelationships within the departments. So again, 2 guidelines here help you decide what type of layout or product variety you're gonna have to design your product department. Another guideline here that can tell you additional information. So the product family departments. So we talked about this already. We have again, I use the example of the cell phone, the Samsung, it could be iPhone. So you have this major cell phone, and then you know that you have multiple models that are coming from these design. So that we can call this a product family, right? You have multiple products, but in essence, they are just different on some specific areas, but most of the product is the same. So that's what we can use, or we can define as a product family. Aggregate medium volume variety parts into family based on similar manufacturing operations or design attributes. Machines required to manufacture the part family are grouped together to form a cell, thus the label of cellular manufacturing. We have an algorithm that we're going to discuss this afternoon. It's called the direct clustering algorithm, or DCA. It's a methodology, it's a simple procedure that clearly illustrates the important features of the cell clustering problem. The direct clustering algorithm is based on a machine part matrix in which 1 indicates that the part requires processing by the indicated machine. A blank or a 0 indicates the machine is not used for the particular part. Okay, so as I mentioned, you have multiple products that are similar. They will have a route sheet, route that they have to follow in the production facility. 1 will mean that you need to use that machine or that process. 0 will mean that you can skip that machine or that process. So here are the steps of the methodology. Direct clustering algorithm has the following steps. So I'm going to read them, and then we're going to try to apply them with an example. So step 1, we need to order the rows and columns, sum the ones in each column, and in each row of the machine part matrix. Then we're going to order the rows top to bottom in descending order of the number of ones in the rows, and order the columns left to right in an ascending order of the number of ones in each. Where ties exist, we're going to break the ties in descending numerical sequence. Okay, so we're going to start by adding all the ones per row, all the ones per column. And then we're gonna rearrange this matrix based on those values. For the ones, the total of the ones for the rows and the totals of the ones in the columns. So order the rows top to bottom in descending order. Okay, so we're gonna start top larger value, then we go down, and then left to right in ascending order. So from left to right, smallest value, highest value to the right. Then you're going to sort the columns, beginning with the first row of the matrix. You're going to shift to the left of the matrix, all columns having a 1 in the first row. So we're going to continue the process row by row until no further opportunity exists for shifting columns. After we're done with the shifting from the columns perspective, left to right, we're gonna move to the rows, and column by column, we're gonna begin with the leftmost column. We're gonna shift rows up when opportunity exists to form blocks of ones. Performing the column and rows rotation is facilitated by the use of spreadsheet. So we can do this in the computer. So I mean, we can keep the right location of the ones, but we can do it by hand. So we're gonna form cells, and we're gonna look for opportunities to form cells such that all processing for each part occurs in a single cell. So let's look at one example. Okay, so here's what I'm referring to. This is the matrix. At the top, we have the machines. And the machines are identified by number. So in this case, we have 5 machines. And then we have a part number here. And we have these many parts. 6 parts. And you can see that part 1 has to go through machine 1 and 3. Right, part 1 has to go through machines 1 and 3. Part 2 only needs to be processed in machine 1. Part 3 needs to be processed in machine 2, 4, and 5. Part 4 needs to be processed in machine 1 and 3. Part 5 only in machine 2. And part 6 in machines 4 and 5. So this is the information we're getting from this matrix. The question is, using this information, can we design some manufacturing cells? Meaning that, can we separate these machines into cells so they can focus on specific parts? Okay, and that's what we are trying to do. So step one, we start by adding the total of ones per row and per column, right? So that's what you're seeing here. 1 plus 1 is 2. This is 1, this is 3, this is 2, this is 1, and this is 2. That's the summation per row. And then here you see the total per column. 3, 2, 2, 2, and 2. And that's part of the first step. We're not done with the first step, but that's the first portion. What's next is the sorting. So we need to sort this rows and columns. So applying step 1 of the direct clustering algorithm, the rows are ranked in descending orders of the number of ones. So you will see now, from this, we started with a 2, 1, 3, 2, 1, 2, right? But we are now sorting in descending order per row. So we have 3, 2, 2, 2, 1, 1. That means that we move this row to the top because the total is 3. And then we move all the 2s after 3, and then we are left with the 1s. So that's how this sorting is done. As you can see, there are ties, right? This number, and this number, they are the same. So how do you break the ties? You break the ties by the part number. So you put the highest one first, 6, then 4, and then 1. These two are the same 2. So you put the highest one first, and then the lowest one. So that's how you break the ties, by the number of the part. And then you sort in descending order. And then for this part, you're also sorting, but you're sorting in ascending order. Okay, so column 1 used to be here, is now at the end because it has the maximum value, which is 3. And then the rest of them were 2s, and the ties are break by the highest number. Okay, so ties are broken in descending numerical sequence. The row order sequence of the part numbers is 3, 6, 4, 1, and 5, and 2. Likewise, the columns are arranged in ascending order of the number of ones, with ties broken in descending numerical order. The resulting column order sequence of the machine numbers is 5, 4, 3, 2, 1. So everything we did in the first step, we start adding. Okay, we start here. We're adding the totals per part number and per machine. So rows are the part numbers. So we add the totals 2, 1, 3, 2, 1, 2. Then per column, we also add the totals 3, 2, 2, 2, and 2. Once we do that, we move to the shifts of these columns and rows. So we start with the rows. We sort them in descending order. We break the ties based on the part number, and the rows are sorted in ascending order. And we also break the ties based on the machine number. Okay, so that's step 1. In step 2, involves sorting the columns to move toward the left, all columns having a 1 in the first row, which represents part 3. Okay, so let's go back here. You see here we have 5, 4, 3, 2, and 1. So now we're going to start doing a shift of these columns. If you remember step 2, we're going to sort the columns beginning with the first row of the matrix. Okay, so we're going to look at the first row, and we're going to shift to the left of the matrix, all columns having a 1 in the first row. We're going to continue this process row by row until no further opportunities exist for shifting columns. So this is the last step of step 1, or the last thing that we did for step 1. Now we're going to start with step 2. So I'm going to look at this first row. Let me change the color. So I'm going to look into this first row, and I'm going to see whether for each machine type, if there's a 1 in that first row. The answer is yes. There's a 1 here for the first machine. There's a 1 here for the second machine. There's no 1 here, and there's a 1 here. So that means that I can shift this to the left. Okay, and then I'm done with this first column. And that's what's happening here. See, I move 2 to the left. So I move 2 to the left. So this column is moved to the left. Okay. Then check all the other columns. There's nothing happening here. Then I move to this one. Yes, I have a 1 here, but these 3 are already fixed because I already moved 2. I cannot move again the column that's already moved. So if I move 2, then that's fixed. Next one that I can move is 3, but 3 is already in the same place. And then since this is the last one, we cannot move it. So we did all the possible shifts to the left based on the machines that we have available. And that's step 2. We're gonna do the same process now but looking at the rows. So now we're gonna go column by column. I'm sorry. We're gonna look. Right now we were looking at the rows. Now we're gonna look at the columns and see if there's any opportunities for us to move up any of these rows. So step 3 consists of sorting the rows by moving upwards, rows having a 1 in the first column that are already not located as far toward the top of the matrix as possible. Since none can be shipped further for item machines 5 and 4, the first row to be moved is that for part 5 based on its processing requirement with machine 2. Okay, so let me go here. Okay, so this is the matrix after completion of step 2. I'm gonna do step 3. I'm gonna start looking at each column now. So for this column, you see I have a 1 here and 1 here and nothing else, so I cannot move any ones up. Same thing here, 1 here, 1 here, nothing can be moved. But then I go here, and I have this one that can be moved up. So that means that I can put that in here, right? So row 5 is gonna be moving between 3 and 6 and 4. And then I move to the next one. This is gonna be under this one, so it is already up. And the rest of them are gonna have the same thing. So this is how they gonna look like at the end. So this is row 5 that was moved up. 5 was moved between 6 and 4. And the rest of them, 4, 1, 2 are staying the same. 4, 1, 2. And at this point, we're done. I mean, we're done with the processing of the matrix. The question now is, can we form cells based on this information? The answer is yes. The machines can be grouped into 2 cells. You see here we have machines 4, 5, 4, and 2 serving parts 3, 6, and 5. These machines 4, 5, 4, and 2 are not involved with parts 4, 1, and 2. So that's why we can separate them and form a cell. Same thing here. Machines 3 and 1 are processing 4, 1, and 2. So that means that we can separate that cell from this cell, and they're going to be focusing on parts 4, 1, and 2. Okay, so from this original matrix, we're able to identify 2 possible cells in which we can separate these 2 processes, and we can separate the cells and plan for the design of our department. So instead of having all these machines in the same location, we can separate them and place them as separate groups. But that's not the case always. Okay, this is a very good example because we can find a good solution. Here's example number 2. Suppose that applying the DCA algorithm, this is the original matrix. We have 1, 2, 3, 4, 5 machines in 6 parts. So we go through the same process for example 2. And this is the final product after applying the DCA algorithm, the direct clustering algorithm. Notice that because machine 2 is needed for parts 3 and 5, there's a conflict. Okay, so if we try to separate this machine, like you see machine 2 is needed for part 3 and part 5. So if we try to split this, machine 2 is needed in both cells. So for example here, 2 cells can be formed, one consisting machine 4 and 5, and one consisting in machines 1, 2, 3, and 1, 2, 3. But the machining required for part 3 of machine 2 has to be resolved. So part 3 still needs to use this machine. And so what this is trying to illustrate is that we will not get a specific split or a clear split every time we run this algorithm. So how do you resolve this problem? There's a couple of options. If we do the split the other way around, if we include 2 as part of this cell, we will see the same problem. So what's the solution? If machine 2 and 3 can be located relatively close to one another in different cells, then part 5 could be processed by machines on the boundaries of the cell. So the idea is, let's say you put machine 2 here. Maybe you can have a cell going in this direction, and then another cell going in this direction. And that machine can be used by both cells. That's one solution. Another option would be to purchase a second machine of type 2. In that way, you can clearly separate the 2 cells, but obviously that's going to be a little bit more expensive. You buy the machines and you have a 2 now, duplicate. You can separate the cells, but you need to buy another machine. But those are 2 possible solutions. Okay, so I think I'm gonna stop here. I'm gonna let you look at this on your own before we try to attempt to solve the lab. So if you can review this, and then on Wednesday we can attempt to solve the lab in class, and we can discuss it also in class. Then we'll continue our lecture. Any questions? So I'm gonna update the lab due date to Wednesday. Don't worry about the lab. It's gonna be due on Wednesday during our class. We're gonna work on it and we'll discuss it, and then we'll move to the next material. I'm gonna ask for a larger classroom, so I will update you if we get a change in the classroom. I'll let you know via email. So keep that. Check your email between today and on Wednesday so you get the update. Any questions? No. So I'll see you. Yes, sir. No, I mean you can work on a sheet of paper, and then you can just upload that, you know, picture, take a picture and upload the file to Canvas. Okay. So I'll see you on Wednesday. Good job.